general formula for finding the area of a shaded region is quite simply the area of the larger figure minus the area of the smaller figure. In question number one, they're asking for the area of the shaded region. In the company diagram, right triangle ABC is inscribed in circle O. Diameter AB is equal to 26, CB is equal to 10. Find the nearest square unit the area of a shaded region. So I use this general formula to help me simplify this problem. Well, I'm going to take the area of the larger thing. That's going to give me the area of everything there. And then I'm going to pull out or subtract the area of the part of that bigger thing that I don't want, which will leave me with the area of the shaded region. Now, in this particular case, I can say that the larger figure is actually a semicircle. So what I like to do is substitute in for the area of the larger the formula for a semicircle, which is 1/2 of the area of a whole circle, which is 1/2 pi r squared. And then I ask myself, well, what's the smaller thing that I don't want? Because if I have the area of half of that circle, I still have that white part, which includes that right triangle. Oh, it's a triangle, right? So I'm going to subtract out the formula for that triangle, which is 1/2 its base times its height. So I really just need to see, do I have all of these things? Well, let me put some of those numbers in that were given to me at the beginning. AB, which was also the diameter, is 26. And CB is 10. That's one of the sides of that triangle. Well, I could see that 26 is the diameter of the circle. So that means I could do one of two things. I could actually card that up and know that if the diameter is 26, then the radius is going to be half of that, which is 13. Now I could just substitute that in, but why not a little practice here? That means the area of the whole circle will be 169 pi. So if I just substitute that in here, the 169 pi into my pi r squared, I get 1/2 of the whole circle, which is the semicircle, which is 1/2 of 169 pi. Well, I need to subtract from that semicircle the area of that triangle. However, it's important to remember that bases and heights are always perpendicular. So while this 10 could be the base, it's this side right here, AC, I'll put an X there, which is going to be the height. And we need to remember now that the only way we can find a third side of a right triangle, given two sides, is through the Pythagorean theorem. So on the side of my paper, I'm going to say a squared plus b squared is equal to c squared. One of my legs is going to be my a. I'm going to make the other leg my x, and it's going to be equal to 26 squared. And I'm going to get x squared is equal to 676. 10 squared is 100. I'm going to bring it over to the other side and subtract. X squared is equal to 576, which take a square root. Our x is going to be equal to 24. So this right here, this side is going to be 24. So that means that the area of my triangle is going to be 1/2 of 10 times 24. Now, this question is asking for the nearest square unit, so I could actually just put that all in. Well, this is going to be kind of messy, my 169 pi cut in two, so I'm just going to bring that down there. But this one I could do in my head. Half of 10 is 5. 5 times 24 is going to be 120. All right, so let's get that in the calculator. So let's clear this out. I got 1/2 of 169 pi I like to put enter before I subtract that out. And then I'm going to pull out the 120 that we don't need. And we get to the nearest, they're asking here to the nearest square unit. So that's going to round off to 145. Again, area, right? In the company diagram, a circle with a radius of 4 is inscribed. Well, we know the circle is inside the square. Therefore, it's pretty simple to deduce that when we say the area of the larger minus the area of smaller, in this case means we'll find out the area of the whole square and then subtract out the circle, which is the white part, which will leave left over the shaded region. Well, you might remember that the area of a square is side squared, right? So it's really going to be whatever the side of that square is squared, which is the area of the square, minus the area of the circle, which is, of course, pi r squared. Well, one deduction that we need to make is that since the radius is 4, right? If I wanted to card that up, a radius of 4, it means the diameter would be 8. Well, as you can see, since that circle is inscribed, the diameter is going to be the same as the side. So the side is going to be 8. So I can already come over here and say, well, 8 squared, well, that's 64. And then my pi r squared is the circle. Well, I already have the card set up, so why not just go over here and say 4 squared, 16 pi. And this right here would be the area of my shaded region in terms of pi. We wouldn't be able to subtract that out without the calculator and an irrational decimal. However, they wanted it in terms of pi, and you can see our answer is right there. 64, the area of the square, minus 16 pi, the area of the circle. Okay, here's a problem where they give us a rectangular plot of land. It becomes a little bit more of an application. They're designing a flower garden in the shape of 2 semicircles and a circle in the middle. He's going to fill the gardener, Mr. Petrie, with wood chips. 1 bag of wood chips covers 5 square feet. How many bags must he buy? All right, there's a bunch of things going on here. So even more important to first simplify that. Well, if we're going to know how much, we want to figure out how many wood chips is going to cover this shaded area. We need to find the shaded area. And well, how do I find the shaded area? I'm going to take the area of the larger and subtract the area, of the smaller. Well, what is the larger thing? Well, it says quite clearly, and you can see it right there. It's a rectangle, and we need to know that, of course, the area of a rectangle is length times width. So it's going to be the length and width of the rectangle minus the smaller things inside, which is a semicircle, another semicircle, and a whole circle. Well, if I put that all together, that equals 2 circles. So that equals pi r squared, which is 1 circle, times 2, which is 2 pi r squareds. All right, there we have it. So let's see which information is pretty simple to attain here. Well, I could see the length and the width is handed to me twice in the picture and in the problem. So I could certainly just plug in my length and my width, which is going to give me 200. And then we need to make the deduction that if I were to card this up, that the diameter is given to me because it happens to be the same as the width, which means the radius will be 5, half of that, and the area will be 25 pi. So I'm going to pull out 2 25 pi's. Well, of course, that's going to be 200 minus 50 pi, right? 2 circles. Well, that right there is going to end up giving me the area of the shaded region. However, if 1 bag of wood chips covers every 5 square feet, we're then going to want to know how many times 5 goes into that number to equal the number of bags. So now I'm going to rely on my calculator when we're calculating with pi universally. 200 minus 50 pi. Again, before I divide, I like to see, well, that's right there, the area of the shaded region. And I want to see how many times 5 goes into that. So how many bags I'm going to need. I'm going to need 0.584073464, right? Well, look, whenever you're going to a store to buy things like bags that cover a certain area or cans of paint in the near future that paint a certain area, you always, regardless, need to round up. Even if that number 5 was a small number like 1, we still would round up because we want to have too much rather than too many. So if I'm going to round that up, I think it's going to come out to 9 bags. Mrs. Brown plans to carpet her living room floor. She has plans, and the living room floor is a square, as we could see in that picture, 20 feet by 20 feet. Well, side squared, right? She wants to carpet a quarter circle. Oh, they're being very helpful in telling us that that's a quarter circle, as shown in the diagram. Find the nearest square foot. What part of the floor will remain uncarpeted? So you do need to read through that to realize that this is really what they're asking for. That's kind of like the shaded region in this particular problem. So again, I'm going to simplify my life by saying, well, I just need to take the area of the larger figure here and subtract out the area of the smaller. And clearly the larger thing here is a square, and the formula for that is side squared. And I'm going to subtract out the area of the smaller, which in this case they told me is a quarter circle. Remember when we first started going over the general formulas of a circle and half circle and a quarter circle? A quarter circle would obviously be 1/4 of the whole circle, which is pi r squared. Now, if we started with the area of the whole square, they're giving us the side right there. They gave it to us twice in the picture and in the word problem. So it's going to be 20 squared minus 1/4 pi. And I can also see that that also happens to be, this is like the center of the quarter circle, right? If you can imagine the circle going all the way around here, right? That's the center, and that 20 is also the radius. I can just put it right in there. And it says to the nearest square foot. I'm ready to go, actually. I could just put that all into my calculator. However, I like to simplify things. First, 20 squared is going to be 400. And 20 squared here is also going to be 400. And a quarter of 400 is 100. So it's going to be minus 100 pi, even though we could have just put that into the calculator at that moment. So we're going to have 400 minus 100 pi. And it's going to be 85.84, which to the nearest square foot would be 86 square feet. Okay, now we got a couple problems that are similar, so I'm just going to choose one of these to do. Let's do number 6. So number 6, in the diagram, right triangle ABC is inscribed the circle. BA is a diameter. Okay, great. That means it goes through. There's some center of the circle over here. BC is 6, and AC is 8. Find the area of the shaded portion to the nearest tenth of a square centimeter, right? These are all centimeters, right? So again, let's simplify my life. The area of whatever I see is to be the larger figure here, and then it's going to subtract out the area of the smaller figure. And in this case, the larger figure happens to be a circle, and the area of a circle is pi r squared. And the smaller thing is a right triangle, which is going to be 1/2 base times height. Well, let's see what we have for the circle. Well, I go, okay, I need the circle. I'm going to card up. I'm all ready to go. However, none of those 4 things are given to me. So there is another calculation. Once again, we could see that it is the diameter that we need, which happens to also be the hypotenuse of this right triangle. So I could use the Pythagorean theorem on my side over here to figure out that 6 squared plus 8 squared is equal to my c squared, which is, this is a famous right triangle, by the way, because it comes out to exactly 100, and I square root, and I get 10 is equal to c, right? So here, this is a 6, 8, 10 right triangle. If you had memorized that, you could have just put that in there, which is fine. But that means that the diameter of the circle is 10, which means the radius is half of that, and that the area is going to be the radius squared pi. So 25 pi is the area of the circle. Now, the base and the height happen to have been given to us in this problem because it's always going to be the two perpendicular sides, the legs, the 6 and the 8. So it's going to be 1/2 6 times 8. Now, they do want us to round this off to the nearest square centimeter. However, you know me, I like to simplify. 25 pi is as much as I'm going to simplify that, but half of 6 is 3 times 8 is 24. So that's really would be our answer in terms of pi. It also makes it a little easier to get into the calculator. 25 pi, remember, second power, minus 24 is equal to 53 point, that irrational decimal says to the nearest tenth. So I need that 5. I also need that 3 to look at that 5 and say, oh, I'm going to keep that 5 as it is. And it's going to be 54.5. Here is a case where we have another application problem with two circles. Interesting. So they're basically saying that there's a circular road, right? So they'd really just want us to find out the area of that shaded region. And they give us the inner and outer radius, the radii, right? And they tell us that once we know that area, we could calculate the cost of paving this road, this circular road, which will be about 78 cents for every square foot. So how much is it going to cost us? All right, so let's go back to the beginning here and first figure out the area of shaded region. Now here you might say, well, they're both circles. It's true. Well, but we have a larger circle. That's going to be a pi r squared of sorts. And we have a smaller circle, which is going to be another pi r squared, right? So in this particular case, you could see obviously the larger is going to be 50. So you're going to pi times 50 squared. And then the smaller radius is going to be 36 squared. And that's going to be 2,500 pi. And then I think that's what, 1296 is 36 squared. Equal to 1204. Okay, so I am going to clear this out. I'm just going to keep on going here. Hey, I make mistakes like everybody else. So it's going to be 1204 pi times 78 cents. See, I made a silly mistake. So now I can multiply that by pi times 0.78, and that should give me my answer of $2,950.33. There we go. Silly me. Silly me. Okay, and that brings us to our last question, number 8. In the diagram below, we have a circle inscribed in a rectangle. And again, finally, we're going to find the area of the shaded region. So the area of the larger minus the area of the smaller. The larger is obviously a rectangle, and the smaller is a circle. Well, we do need to come to the conclusion here that when we have our length and our width, that it's going to be 21 times 16, right, as the area of our rectangle, minus our radius, pi radius squared, right? And if we multiply If we wanted to simplify this before we put this in the calculator, 21 times 16 is 336. So this is going to be 336 minus 64 pi. That would be our answer in terms of pi. However, they wanted us to the nearest integer. So we're going to put that in the calculator. There's my 336. It's already there. My 64 pi. And there's your answer. To the nearest integer is going to be 135. And there you have it. That concludes your homework. I hope you found this useful. And if you have, you could subscribe to Mr. Frank's YouTube channel. See you soon.